Okay, in section 4.2b, we're going to keep talking about experiments, and we're going to talk about how things can go wrong. So in this section, we're going to talk about how to experiment badly. Before we do this, I'd like you to open your textbook to page 239. At the bottom of the page, it says how to experiment badly, and I'd like you to read over to how to experiment well, and also read the example that's on page 240. Pause the video and go to your book and read. So many laboratory experiments use a design like the one in the online SAT course example. The experimental units, treatment, and then measured response. In the lab environment, simple designs often work well. Field experiments and experiments with animals or people deal with more variable conditions. Outside the lab, badly designed experiments often yield worthless results because of confounding. So if you look at the example on the SAT prep course, you can't really tell whether there was the experimental units were the students, the treatment was the online course, and the response was an increase in math scores. But we didn't know, were they due to their math course or were they due to the online course that they were taking? So there was confounding involved. How to experiment well. The remedy for confounding is to perform a comparative experiment in which some units receive one treatment and similar units receive another. Most well-designed experiments compare two or more treatments. Comparison alone isn't enough. If the treatments are given to groups that differ greatly, bias will result. The solution to the problem of bias is random assignment. In an experiment, random assignment means that experimental units are assigned to treatments using a chance process. So there are 4 principles of experimental design, and you're going to have to look at studies and explain the different parts to all of these. So first, the basic principles are comparison. Make sure you're using a design that compares 2 or more treatment. Random assignment. Use chance to assign experimental units to treatments. Doing so helps create roughly equivalent groups of experimental units by balancing the effects of other variables among the treatment groups. Control. Keep other variables that might affect the response the same for all groups. And replication. Use enough experimental units in each group so that any differences in the effects of the treatments can be distinguished from chance differences between the groups. A completely randomized design, the treatments are assigned to all the experimental units completely by chance. Some experiments may include a control group that receives an inactive treatment or an existing baseline treatment, maybe like a placebo if you're talking in the medical world. So in a completely randomized design, we have our experimental units, we have our subjects. Then those subjects are randomly assigned to 1 or 2 groups, maybe even more. They're given treatment 1 for group 1 and treatment 2 to group 2. Then you bring the results together and compare them between the two.